Every society is plagued by problems that are particularly hard to solve precisely because nobody can see them. So to give you an example, the ancient Greeks were remarkable innovators, both in politics and in the sciences. But even the most enlightened thinkers of the day thought that women were inferior to men and that slavery was actually good for slaves. So in our day, we're confronted with a host of difficult problems: poverty, violence, environmental and financial catastrophes. I believe these problems are caused in part by a deeper form of inequality than the one that plagued the Greeks. And until we can all see this root cause clearly, we're going to struggle to solve our more serious problems. So the root cause is very simple. So we underestimate ourselves. I first saw this through my own experience. I'm a mathematician and playwright, but when I was growing up, I had deep doubts about my abilities. These were confirmed when I almost failed my first calculus course at university. Fortunately, I was saved by the bell curve that brought my mark up to a C minus, but unfortunately, I also got the lowest mark in my creative writing class. So when I graduated from university, I didn't think there was too much I could do. It took me a long time to develop the confidence to go into these fields. And 15 years ago, I started a charity in my apartment called Jump Math because I didn't want kids to struggle in math the way I had. Jump produces materials for students, training and resources for teachers, and our student books are used by 150,000 children now in Canada and the US. We also participate in rigorous research, including 2 randomized controlled studies. So to give you an idea of the extent to which we underestimate ourselves, I'd like to start with a case study. At the beginning of grade 5, a Toronto public school teacher, Mary Jane Moreau, tested her children on a test called the TOMA, a standardized test of mathematical ability. And the average mark in the class was in the 54th percentile. And there was quite a range of marks. The lowest mark was in the 10th percentile, and the highest mark was in the 75th percentile. So I've seen this same range in all of the schools I've visited. This would represent about a 3 grade level difference between the top students and the bottom students as early as grade 5. So Mary tried using the JUMP lesson plans for a year, and she retested her kids at the beginning of grade 6. And that's what the bell curve looked like. The lowest mark was in the 95th percentile, and the average was in the 98th. And at the end of grade 6, all but one of the students wrote the Pythagoras math competition. And 14 of the 17 got awards of distinction, and the other 3 came close. Now, this is just a case study, but in a much larger randomized controlled study, students in JUMP classes progressed at twice the rate of the control group. And there's a growing body of evidence in cognitive science that virtually every child is born with the capacity to do well in any subject. So the question is, why don't we see these kind of things in our society? There are many reasons, but I'm going to focus on 4. First, until recently, there haven't been many rigorous studies in math education. Some people have argued that kids should be allowed to discover things on their own, and others that they should be taught more explicitly. A new body of research in cognitive science suggests that a balanced approach called guided discovery produces the best results. So in guided discovery, children are given opportunities to discover things for themselves. It guides their learning by providing lots of feedback, practice, review, by breaking problems into more manageable steps. So if you're interested in this research, you can find a summary in an article I wrote for Scientific American Mind at jumpmath.org. Now, it's very important that we pay attention to this research in education because we're often swayed by arguments that aren't founded in very solid data or evidence. So, for instance, some people argue that because we have the internet, kids don't need to learn facts now. They need to learn how to find and analyze facts. Now, there's some truth to this, but research suggests that kids who don't know basic facts like multiplication tables often struggle to become good problem solvers. Their memories are constantly overwhelmed trying to remember the facts, and they have trouble making predictions and seeing patterns. So recently I tried a lesson on multiplication with a grade 3 class using some charts I'm going to show you. I was very surprised. The kids managed to work charts in one lesson. And afterwards I found out that some of them were only in grade 2. So I hope you'll do as well as these grade 2 students. So I asked the kids to write the first 3 multiples of 3 in a row like this, and then put the rest underneath and add zeros. The kids very quickly saw a pattern in the tens digits and also in the ones digits. Now they saw lots of other patterns, but I don't have much time today, so maybe you can think about those on your own, maybe when you go home or having trouble sleeping. So after a little practice, the kids were able to write out these charts from memory using the patterns they found. And then I told them to think of the touchpad on a phone. If you know the position of the numbers in the chart, then you know how to multiply by 3. So for instance, the number 18 is in position 6, and 6 times 3 is 18. And the number 24 is in position 8, and 8 times 3 is 24. Now I'm a mathematician, but I didn't realize until a few months ago that if you put other odd numbers like 7 and 9, or the multiples in rows of 3 like this, you see similar patterns. Now, if this was a grade 3 class, some of you might already know your times tables. I know there's a lot of physicists here, so I expect that's the case. And some of you might be very good at seeing patterns. So how can I keep you engaged in the lesson? Well, the beautiful thing about mathematics is that if you know the math, you can always create bonus questions that don't introduce new skills or topics, but that look harder. So a good bonus question here would be, can you see any patterns that are common to all of the charts? If you look at the tens digit, for instance, you'll notice in the chart for 2, the tens digit increases by 1. In the chart for 4, it increases by 2. In the chart for 6, it increases by 3, and so on. The tens digit always goes up by half of what you're multiplying by. Now, the really exciting thing, and I've seen this with thousands of students, is that when students who are initially slower see that the extra work is possible, that they can do it, they start speeding up dramatically so they can get their bonus questions. So we don't have to hold back faster students to close the gap. Mary Jane's results showed this very clearly. Now these are fairly simple charts, but you can teach much more complicated things using guided discovery, even problem solving. But to teach this way, you have to know the math well. So this leads me to education. Teachers are my absolute heroes, but many teachers will admit that they don't know the math and they don't love teaching it. At a teachers' convention, I asked a large group of teachers why, when you divide 7 by 2/3, you can flip and multiply. And someone yelled out, because you get the right answer. So that's true. To give teachers the professional development they deserve in mathematics can be very expensive. So at JUMP, we decided to take the expertise of a team of mathematicians and expert teachers and put that knowledge into clear, comprehensive lesson plans so that teachers can learn the math as they teach it. If you register at jumpmath.org, you'll find lessons for Canada, the US Common Core, even a video that explains why you flip and multiply. Now, a third reason we struggle to teach math well is because we think it's an inherently hard and boring subject. Now, you wouldn't think that learning to read numbers is very exciting, but listen to these grade 2 students.
315,425.
Unbelievable. Okay, I think we have to go up to billions. The next is billions. All right, this is the last one. Okay, you think you can do billions? Yeah? Who thinks they can do billions? Yeah? You think you could do it? I think you could do it. What do you think? You want to try it? See, you did it. That's fantastic. Okay, I give up, you guys. I can't really make it any harder. I could go to trillions. So I've seen that same kind of excitement at every grade level. I've seen kids here for math, and I've seen them beg to stay for recess. I even broke up a fight once by telling the bully that if he didn't apologize, I wouldn't give him his bonus question. And he apologized. And this brings me to my last and only radical point. We're confronted with a circular problem in education. We teach math and other subjects in a way that causes many students to struggle. And this reinforces our belief that only a few are born with ability. But what if this belief itself was the main cause of our problem? As early as grade 1, children start comparing themselves to their peers and deciding who's smart and who's dumb in subjects like math. Once children have decided they're not talented, their brains stop working efficiently. They stop persevering, paying attention. They even develop anxieties and behavioral problems. But teachers like Mary Jane have shown that we don't have to teach this way. Once you've seen how much children can learn and how much they love learning, you have to admit that we're living in an age of intellectual poverty. If children are born with anything, it's a sense of the invisible beauty of the world. They love seeing patterns, making connections, solving puzzles, as you can see from this lesson of children learning about, of all things, binary codes. But the majority will lose this sense of wonder and curiosity before they grow up, because as a society, we expect so little of ourselves. Every child has a right to fulfill their intellectual potential, just as they have a right to develop healthy bodies. And we don't have to wait until we've invented some miraculous new technology or discovered a new method of teaching to guarantee this right. We could accomplish more now as a society than all the towering geniuses of the past. For if we were